All right, this is going to be the part 2 of area of regular polygons. Part 1 covered how to find the apothem. We need to find that. A lot of the times they don't give it to us. We've got to find it so that we can plug in, find the area. So the warm up first, we're going to go ahead and start off by finding B, C, F, and G. B and C are going to be on the 30, 60, 90 triangle over here. And the F and G will be on the 45, 45, 90. So we're going to practice this as well because this is a way that you can, this is one of the methods you can use for some of the problems. First, let's start off with this 30, 60, 90 to find C and G. Let's go ahead and draw in our 30, 60, 90 table of 1 square root of 3 and 2. Here we're given across from the 30 is going to be 5. And then B is across from the 60 degree. And C is across from the 90 degree. So when we're solving this, we'll go ahead and first solve for B. When we set these proportions up, we would have 1 over 5 will be equal to square root of 3 over B. When we cross multiply this here, we're going to just wind up with B times 1, so we have B equals, and simply just the 5 square root of 3. And we're done with that one. Now we'll take a look at finding C. We'll use that same 1 over 5 right here, and then now we're going to do equals 2 over C. We'll cross multiply. C is going to equal 10. All right, now for the 45, 45, 90 down here. 1, 1, and square root of 2. F and G are both going to be across from the 45 degrees, and how we know it's 45 degrees is because we have this 90 degree here, and we have 2 congruent angles. That means they have to be 45 each. So we can look at F in one of the columns and G in the other. And when we solve, we're only going to have to solve one since they are congruent. So here we'll have, just use F, and then across from the 90 is 15. So here we have 1 over F is equal to the square root of 2 over 15. Now when we cross multiply here, we're going to wind up with F square root of 2 equals 15. We need to divide both sides by that square root of 2, so it cancels by F. And we wind up in the situation where we have a radical in the denominator. We're not allowed to, so we need to rationalize. The way I've taught rationalizing is a shove it and leave it method. Bring your numerator over. We're going to shove the square root of 2 to the top, and we're going to leave the 2 by itself. We are done solving. 15 cannot be divided evenly by 2. So here, as a reminder, F is going to be equal to G, which equals 15 square root of 2 over 2. All right. Your area of a regular polygon, what we're going to do is you're going to see this uppercase A and the lowercase a. The uppercase A stands for area. The lowercase a is apothem, what we talked about with part 1. And then the big P is the perimeter. So we're going to take the apothem times the perimeter and divide it by 2. So these steps right here are basically, we're going through the exact same process what we did in part 1. We created a triangle, we found the central angle, and then we solved using different methods. We can use 45, 45, 90s or the 30, 60, 90, or we can use our trigonometric functions. Generally, I will use trigonometric functions, but I may change it up. So here are the 3 things we're going to do. We're going to first find the apothem, then we're going to find the perimeter. That's the lowercase a and the uppercase p. And then we plug it into the formula. We are going to leave this problem in simplest radical form. So we're going to leave all of our square roots, all of those radicals in there. So first, to find the apothem, we remember from part 1, we need to find the central angle. And so we're finding the central angle of angle QPR. And we have 6 sides, so n is 6. So when we divide 360 by 6, the central angle is going to be 60 right here. And then what we do is we want to take half this triangle. And that's what's up here for number 1, create a right triangle. So we create this. We can pull this to the side and look at it. Here's the side length is 10, so when we have this right triangle, this leg right here will be 5. We remember that we need to take half the angle, so this will be a 30. And then down here we'll have a 60. And our apothem is right here. So trigonometry or 30, 60, 90, whichever method. I'll go ahead and do 30. This is an easy 30, 60, 90. So I'll just go ahead and do that. Our 30, 60, 90, we got 1, square root of 3, and 2. We have across from the 30 is 5. And across from the 60 is A, what we're looking for. So we can set this proportionally. When we cross multiply, we're going to get A, the apothem, is equal to 5 square root of 3, leaving it as in the simplest radical form. There it is. So now we find the perimeter. The perimeter, we simply just take these sides. How many sides we have? 6. Since it is a regular polygon, all sides are congruent. Times the side length of 10, we're going to get 60. And this is what we will plug in for our formula. So with our area being apothem times perimeter over 2, our apothem of 5 square root of 3 times the perimeter of 60, all divided by 2. Again, we want to leave it in simplest radical form. So what we need to do here is we need to take our whole numbers, the 5 and the 60, and multiply them, and keep that square root of 3 at the end of it. So we'd have 300 square root of 3 over 2. One last step, the 300 can be divided evenly by 2. So in the end, your area ends up being 150 square root of 3. We have meters, so meters squared. All right, we have 2 more. We're going to find the area of the square, and we're going to keep the area exact. That's another way of saying simplest radical form. Like whenever we deal with pi, when we want exact, we don't plug pi into the calculator. Same thing here. We're going to have that square root at the end of our answer. So first things first, let's find the apothem. Okay, so we're going to find the central angle of this triangle here. N is 4. So 360 divided by 4. Central angle will be 90 degrees. Then step 2, let's take this right triangle. With the central angle, we want half the angle. So it will be a 45, 45, 90 triangle. The 8 is referring to the radius, which is the hypotenuse on this right triangle here. And here's the apothem. So if we use the, I'll go ahead and use the 45, 45, 90 so we have more practice with that. And plus, we'll see what happens on problem number 3 at the bottom. We have 45, 45, 90 table. Here we have across from the 90 is 8. And the apothem is across from the 45. So we'll go ahead and cross multiply here. We're going to wind up with a square root of 2 equal to 8. We need to divide, so we're having to do the exact same thing we did on the last problem. We have to divide by the radical, and then we have to rationalize it. Bring the 8 over, shove the radical to the top, leave the 2 in the bottom. So let's shove it and leave it. And then we need to divide this out. Our apothem will be 4 square root of 2. Perimeter. We have 4 sides. Now what we need to do is we need to figure out what this side is right here. These 2 legs are going to be congruent, so this side and this side are exactly the same. Therefore, this side is 4 square root of 2. To find the entire side length, we just need to add them together. We didn't talk about adding radicals, But the other thing is if we're doubling it, we can just multiply it by 2. We're going to end up with 8 square root of 2 for the side length. And then when we solve for the perimeter, multiplying, again, we talked about this one on problem number 1, whole number with whole number. So 4 times 8 gives us 32 square root of 2 as our perimeter. Now let's plug everything in. All right? Our area of apothem times perimeter over 2. Our apothem we found was 4 square root of 2 times the perimeter of 32 square root of 2 over 2. So now we're going to multiply outside numbers together. 4 times 32 is 128. We multiply the radicands together. Square root of 2 times the square root of 2 gives you square root of 4 over 2. And we need to remember the square root of 4 is a perfect square. So we need to turn this into a 2. So now we have 128 times 2. Then the great thing with this problem, these two 2's cancel out, just like that. So your perimeter, I'm sorry, your area is just 128 centimeters squared. All right, last problem. We'll be rounding to the nearest tenth. All right, find the apothems. Go ahead and go through these steps again. Finding that central angle right here. This is a pentagon, so n will be 5. And central angle, 360 divided by n, we're going to wind up with 72. Look at our triangle, just the right triangle, this guy just right here. And we have the radius, or now that we're looking at the right triangle, is the hypotenuse. The angle, we want half of this central angle. 72 divided by 2 is 36. Looking for the apothem over here. Now with this one, we cannot use any of the special returns. We have to use trigonometry. Please make sure your calculator is in degree mode. Here's our reference angle. When we're using our trigonometry here, we look for our hypotenuse. We're using our hypotenuse. And then the apothem, we discussed this with the previous video. The apothem A is also going to be the A adjacent side. So we'll be using cosine. So setting this up, we'll take the cosine of our reference angle here. 36 is equal to adjacent, which is the A, apothem, over the hypotenuse of 9. Go ahead and set up as proportion to cross multiply. Here we'll cross multiply. We get A. And the other cross product, we're going to multiply 9 times the cosine of 36. And your apothem, rounded to the nearest tenth, is going to be 7.3. Now for the perimeter, we're going to have to find the other leg on the right triangle here. So when we look over here at this is going to be the opposite. So, let me go erase that. To find the leg, I'm just going to use the hypotenuse since it's a whole number. I'm going to have opposite over hypotenuse. That will be sine. Again, with our function, sine of the angle measurement 36 is equal to the opposite, which is our unknown, so I'll just put x, over the hypotenuse 9. We're going to wind up doing the same thing, and we're going to be multiplying. So x is going to be equal to 9 times the sine of 36, which is going to give us approximately 5.3. Just like with problem number 2, that gave us half of the side measurement. So with this being 5.3, we just double it to find the whole side length, 10.6. Now we can go find our perimeter. We have 5 sides times the side length of 10.6, ends up being 53. And we can plug in. Finally, down to the last bit, Finding your area. Just going to go ahead and plug right in your apothegm, 7.3, times the perimeter, 53, all over 2. We click this all into our calculator, we round to the nearest tenth, we end up with 193.5 centimeters squared. And that is it for area of regular polygons. Feel free to search other videos. You can search my YouTube channel or any other YouTube channel for more videos if you'd like more practice.